We're going to have a lot to go through today. So Chapter 12 is measuring, it's not measuring length and area. Yeah. Forgot to change that. Chapter 12 is surface area and volume. There you go. Surface area and volume. Quickly, freshmen. So, Chapter 12, surface area and volume. Today, what we're going to do, we're going to first talk about solids. So, this first section, you don't really have to take notes on. I'm going to go really quick, though, okay? No. All right, explore solids. So, the first thing we got to talk about, what is it? A polyhedron. Once again, don't need to take notes. Just pay attention, right? Don't need to take notes. Just pay attention. A polyhedron is a solid that is bounded by polygons. Okay? All those polygons are called faces. So when we did our little square thing, remember how you had before in the box? The edge, one square, would be called the face. Right? They have to completely enclose the region of space. So ours didn't completely enclose it. Remember, because we had the top open. But notice how they have to enclose something. The faces are all the sides. Highlighted in red is just one of them. The edges are where they meet. And the points where the sides meet is called the vertex. Okay? Easy enough? So a polyhedron has to be any shape enclosed by polygons. So circles are out. Okay? And that is shown right here. Polyhedra is the plural of polyhedron. So shapes that are polygons, notice that all these are rectangles over here on the left. The pyramid, we have triangles for the sides, and the bottom part is a square. So those are still polygons, so those work. These do not work, though, because a circle is not a polygon. So circle for the cone, and then a sphere. All right. How do we name polyhedra? We name them by their base. The base means the bottom. Okay. The base is always parallel to the top if it is a prism. So the prism bases are parallel. Bases are parallel. Notice that they're exactly the same here. The bottom, you see the pentagon. 1, 2, 3, 4, 5 sides. And it is exactly the same as the top. Okay, so it's called a pentagonal, because it's a pentagon, prism, right? If you had a triangle, it would be called a triangular prism. Okay, does that make sense, Carlos? A polyhedra is any shape, any 3D shape that's made of polygons. Okay. A triangular pyramid is where there's only one base. Notice that it's named the triangle because the base is now a triangle, but it's a pyramid because instead of having the same shape at the top, it comes together at a point. All right. So you can have triangular pyramids, square pyramids, pentagonal pyramids. Okay. You can have any shape for the base. Regular polyhedra, yes. Can you picture, you've seen the pyramids in Egypt, right? So that's what it is, except instead of the bottom, the pyramids in Egypt have a square base, like this, and they all come together to a point. This one has a triangular base, like this, and they all come up to a point. I can show you a real example later. I don't have one on me. All right. So imagine it laying flat on the green piece, and then all the other sides are pulled up. Carlos?
Here, the first part of the meaning the very first pentagon that's the base.
Yep.
So,
prism means that the bases are parallel and they're the same. So notice that they have two pentagons. The other option is it's a pyramid, in which case you only have one, and it comes together at a single point at the top. So that's a tip. Okay? Regular polyhedra, regular, remember from when we did polygons, simply means that they have the same sides and the same angles. There are only 5 of them. You guys have all seen this one, the cube. Okay? Notice how all the sides are exactly the same. So for a regular tetrahedron, not important that you know it, but notice that all the sides are the same. See how there's triangles? Regular octahedron, this triangle is exactly the same as that triangle, okay? So regular just means that all the shapes are the same. Here, all the sides are what? What are they called? Yeah, pentagons. 1, 2, 3, 4, 5. This kind of looks like a soccer ball, a pattern on a soccer ball. All right. And then here, there's equilateral triangles. See how all these triangles are going to be the same? Okay. Now, cross sections. You guys have probably heard of this. Cross sections are formed by slicing any 3D object by a plane. So imagine taking a sharp knife and just cutting right through it. Okay. The cross section is the part where it overlaps. So see how it's shown in purple here? Everybody see that? So it's like somebody chopped off the top of the pyramid. The purple slice is called the cross section. Okay, it's going to be a triangle here. Carlos?
Cross sections are always going to be 2D, right?
So good point. The cross section is always going to be 2D. So you're taking a slice of it. So it's going to be on a plane now. So we're moving from a 3D. You slice it for a cross section, it will be a 2D object. Okay. So yes, Abinet? Okay. All right. So slice it through with a plane. There's 3 more I just want to talk about. Notice that these are all cubes, and they're just sliced in different directions. Just like you can cut an onion different ways, right? You can cut shapes in different slices. So here, cutting straight through it, what shape does it form? Square. Here we're cutting at an angle through it. What shape does that form? Rectangle. And here it's kind of off to the side, this little angle. What shape is that going to be? Yeah, I think that would be a trapezoid. Okay. Because you're cutting it right here. I know it doesn't look like a square because you're viewing it at an angle. Okay. Imagine a cube. Let's see if I got a cube. I don't think I have a cube, but imagine if you have a box. All right, picture it, it's almost the same. If you slice straight through it, all the way across, it's going to be the same exact shape as whatever the top and bottom are. You're just cutting it right in half. Or, I think that's half. Right? The shape here, if you cut out the diagonal, it's going to form a rectangle. Right? And the shape here, when you cut off the edge of it, is going to form this trapezoid looking figure. Okay? Really not that important necessarily that we are able to, we're not going to do much with it in our class, but you should be able to recognize it. What?
For calculus, use a lot.
Yeah, for calculus, and it gets harder, but just as an intro to know what a cross section is. Yep. Okay. Here's the cool part of cross sections. They're used all the time in medicine. Have you guys heard of an MRI? An MRI, it looks like this. MRI looks like this. You get on a table, it slides into this big circular thing, and it's kind of scary when you're in there. But these things are giant magnets. So essentially there's a huge magnet going around your body. And how the magnet works is it aligns part of your atoms in your body are very, very slightly magnetic. So it aligns the pieces of your body, and different materials have different alignments, and they can tell what it looks like. So here is a cross-section of a, what is that? Brain. So what they did here is they put a person in, and they literally sliced right through his brain. So if you can imagine taking a slice out of my brain and pulling it out, here's my eye, right? Here's my brain. It's really big. All right. And then here's your, you can kind of see the mouth, all right? So different materials are going to show up differently. Okay. See, now the good question. Question is, where's your nose? If I take a cross section right through my eye, does it include my nose? No. So my nose is right here, it's just we haven't gotten over there. So I took a cross section right here. Does that make sense? Does that make sense why the nose does not show up? Alright. Now this is going to be really cool, so hang on. Alright. This is a whole brain. Okay? What they do, and I'll explain it for a second, so just watch it one time too. What they do is they frequently use MRIs to check for tumors in your brain. It's really hard to get inside your brain, right? Because you're covered by this nice thick skull. So what they do is you go in an MRI machine, and what they do is they take slice after slice after slice. Okay, so just like a piece of bread, except they're very, very thin slices. So if you line up your brain, this guy's looking this way, what they do is they take slice, 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 slice. And what they did here is they all blended them together to make this film. So here it's slicing, here's the eyeball, here's the nose show up, it goes off the screen, here's the other eye, and then now it's going over towards this side of his head and it's getting smaller and smaller and smaller. So let me do it loud. So getting bigger, bigger, slice for the eyeball, now the nose shows up, now slice for the other eyeball, now getting smaller and smaller and smaller. So do you see how it's taking slice, 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 and it's putting it together in a big video? So as you go from the left to the right, the brain is going to start pretty small, going to get bigger right in the middle, right, and then get smaller on the other side. That's why you see this getting big and then small. So right in the middle it gets much bigger. Carlos? Resonance, it's a chemistry term and a physics term. It means the ability to vibrate or at a certain frequency, in this case. Talk about sound at all in physics class? So resonance frequencies, have you talked about those? Okay. It's sounds that combine well with each other. Okay, frequencies that combine well with each other. Kind of cool? Now, this was sliced this way. The next video I'm going to show you is a whole body scan, but it's sliced this way. Okay? So the next video I'm going to show you is sliced this way. So it's going to start at the top of the head, and it's going to take small slices all the way down. Are you ready? Top of the head, shoulders, chest, arms. See the arms? Come in, legs, here are your legs, and feet. Alright? So he's taking very small slices all the way down. Chest, arms, it's still, he's standing like this. Now it's down to the legs, cutting down, knee, and down to the calves, and then to the feet. Does that make sense? So it's as if you took a person and sliced them like bread. And then you took a picture of each one of those slices and put them all together from top to bottom. They're really, really thin. I don't have any idea though.
What he's telling you now is the idea of how graphics is used.
Yeah.
Small pieces, and you think of them as one image.
Yeah.
Like a million pictures.
Yeah, it's a ton. It's a ton. And I think you can set how many you want. So if you want like thick sliced bread, you can cut it wider. Thin sliced bread, you can cut it smaller. So it depends on what you're looking for. If you're looking for something that's big, you can take pretty big slices to find it, right? If you're looking for something that's really, really small, you need to take little tiny slices in order to see it. Okay. Isn't that kind of cool? Can you guys see the body for me? Alright, there's the legs. You see the bone? There's the kneecap. See how it went white there? Bones, feet. Head, shoulders. Here's the chest right here. Arms, see the bones? There's the spine. Here's your leg, kneecap, bone, feet. Alright? Cool? Alright, that's it. Now what I want to do is 12.2. All right, this is the part you need to take notes on. All right, so that was just your intro. We're talking about 3D shapes. Today we're going to talk about 12.2. I want to get through a lot of this stuff. This is the last little section we're going to do. We only have about 12 days left, okay? So we'll see how it goes. We may make a quest out of it, like a quiz test. We may do a test. Depends on how it goes. Nancy and then Asia. Well, you're gonna go well.
No. I know that part, but I don't start.
They start June 8th. June 8th. Yep. All you have to do is show up for finals, just like midterms. I'll answer them after questions after we've done, okay? I'm happy to talk about it. So, Asia? I'm sorry? No, that's just class-based. Okay. So 12.2 is surface area. All right? And I'm going to refer to what we did on Friday when we do this. So surface area of prisms and cylinders, okay? Here's where you need to take notes. Now, the pictures are going to be hard to draw. I understand that, and I'm sorry, okay? If you can either attempt them or you can just skip them, all right? We talked about a prism. Oh, we didn't talk about a prism. We talked about a polyhedron, right? A polyhedron is any 3D shape, and its sides are all polygons. Well, a particular type of that is called the prism. Okay? Prism. So you get a bunch of prisms out here. So, these are examples of prisms, okay? Prisms. Prisms are polyhedron with two congruent faces. Two congruent faces. And they are the bases. They're on the top and the bottom. We talked about this just 5 minutes ago. Notice how my bottom is a 1, 2, 3, 4, 5, 6 with the hexagon. My top is a 1, 2, 3, 4, 5, 6 hexagon.
What?
You see how the faces are both the same? Just like if we look at this sponge, the top would be the same as the bottom. Okay? Does that make sense? Hang on, Carlos. The lateral faces, what does lateral mean? If it's equilateral. Same what? Equilateral means they have the same sides. So what does lateral mean? Sides. Because equi means equal, lateral means sides. So the lateral faces are the ones on the sides of the sponge. So in this case, if we're looking at the sponge or if we're looking on this, the lateral faces are my blue. They'd be here, the front, the back, the left side, and the right side, okay? So bases, top and bottom, lateral sides all the way around. Does that make sense? The lateral edges are where they meet. So just like you would expect, an edge is the corner, the edge is where they meet, that line where they meet. All right, Carlos, you have a question?
Okay, so the polyhedron is a 3D shape with polyhedral sides.
I'm sorry, the polyhedron?
Any 3D shape with polygon sides.
Only polygons as its sides.
And every 3D shape with a polygon with not polygon.
It has to be all polygons.
I know.
Yes, a cylinder, which is what we're going to, like this, has a circle, right? So that would not work. Okay. The surface area of a prism, okay? You don't probably need to write this down, so just choose what you want to write down on this page. Not all of it's that important. The surface area, this is important, so write down these two. These two. The surface area is the sum of all its faces. Okay? The sum of all its faces. So the front, the back, the left, the right, the top, the bottom. surface area is all the faces. The lateral area, just like it says, lateral area is the sum of all the area of the lateral faces. So in this picture, it'd be the blue only. Only the sides of the shape. So it depends. For this one, it would be left, right, front, and back. For this one, it would be all the blue ones. So it would go all the way back. There would be 6 of them. 1, 2, 3, 4, 5, 6, all the way down. Okay. So lateral just means left and right. Sorry, lateral just means the sides. And then if it's the surface area, you also have to include the bases, the top and the bottom. Carlos?
When you say the sum of all the things, the sum of all the area.
Yes, thank you. The surface area is the sum of all the area of its faces. Thank you. Sum of all the area of its faces, okay? What we're going to do now is to find surface area. Now, surface area is not that bad, you just have to visualize it. Right? For some of you, this will come very, very easy. This was my sister and I. This was one thing that I did really, really well. I could just look at a shape and kind of unfold it. My sister, I tried to tutor her. She's younger than me. Tried to help her, and she just hated me. All right? Because she did not get it, and I was just like, you just look at it. And she's like, I don't get it. You just look at it. She's like, I don't get it. All right? So some of you will get it very easily on the first try. That's fine. Some of you may need to work with it a bit, which is why I have all these items up here, okay? If you need some help, come see me and we can actually physically cut the box open and see what it looks like, okay? I got one today. So to find the surface area, you need to use nets. Nets are what we did on Friday. Remember when we had the squares? Yeah. And I asked you to fold them up? A net is what you get when you unfold it. So I asked you to fold it up into a 3D shape. And that is what it looks like if you unfold it. I have one over here. Be sure to remember all the sides. Don't forget about one of them. And the other thing, use shortcuts when possible. For example, this surface area is exactly the same as this surface area, right? The front and the back. So rather than spinning your wheels, make sure you realize, well, this side's going to be the same as this side will be the same as the back, and the top will be the same as the bottom, okay? So use shortcuts when you can. Not all of them you can do that, but some of them you can. Arden?
So the first one, the surface area is right, it's the top base and the bottom base.
Surface area is everything. So top base, bottom base, and all the lateral faces.
Because in that picture, the other base is color blue, but you still, in like the lateral area, you wouldn't count either of them.
Correct. So it's colored blue because it's like overlapped, but your base is down here. Okay, so yes, the lateral faces would only be the sides around it. The surface area would be the lateral sides plus the top and the bottom. Okay, Carlos?
What does lateral and base depend on how you position the base? If you turn that base sideways, would now the base would be the lateral side?
Yes. So it does depend. Right?
So would they be different lateral?
The difference there is that if you turned it on your side, it would not count as a prism anymore, because a prism has to go directly from a straight line from the vertices of the two bases. Okay? If you rolled it over like a log, like long ways, you know what I'm talking about? You would now have it come out and jump back in, right on the side, and that is not a definition of prism. Okay, it's a good question. Right? I wouldn't give you a problem with that. All right. All right. So nets of prisms. Find the surface area of a rectangular prism. The rectangle part tells you what the base is going to look like. So it's going to have a base with a rectangle, with a height of 2, a length of 5, and a width of 6. All right. Sketch the prism first. That's your step 1. All right. How many of you are good at sketching 3D shapes? Okay. So to just sketch 3D shapes, to be honest, it doesn't really matter that you're that the distances look perfect. They should be about correct, but it doesn't have to be perfect. So here, let's draw my height. My height is going to be 2. All right? Does that make sense? My length is going to be 7. 5. Sorry, I don't know where I came up with 7. There's my length. Okay? And my width, I now need to go back into the page. So I need to draw it back into the page like this. My width is going to be 6. So you're going to draw your rectangle and then go back with your last dimension. All right? Then we complete it by drawing parallel lines and closing the box. So yes, I've only shown 3 sides here. Notice how there's only 3 that I've shown? These are all rectangles, even though they don't look like it, because they're drawn at an angle. Does that make sense? They're still rectangles. Think like a box, okay? So, see the box right there? We okay with this? Even though you can only see 3 sides, don't forget it's going to be on the bottom too, right? So that's going to be a full 6. Okay? If anybody needs help with sketching these prisms or anything like that, please come see me, okay? Samantha? And it's okay if it looks roughly okay, it's fine. This is just a sketch, all right? If you need help, I can help you. Yep. Let me take a look at the end. Sorry. Carlos? A cube? Technically, yes. Because a square, which is the base, is still a rectangle, right? So you could technically call it a rectangular prism. I don't think anybody would. They just call it a cube. Yep. A what?
Upward.
What do you mean upward?
That, like going up, like this. Going up.
That's fine with me. Okay. I actually think one of the easiest things to do is just draw a rectangle. Like draw this. And then just throw your units on. Or your numbers, okay? It really doesn't matter, just so you have an idea of what it looks like, okay? Yep. Excuse me? Correct. You could do a rectangle in the front and a rectangle in the back, and then connect the points. That's fine. Okay? The next step is to make the net. Alright? So notice, here's what we started with, roughly. Now theirs is a lot better, but we started with that. And what they ask us to do is to make the net. Now, the net means you need to unfold it. So here's so it's going to be like this. Here's my prism. You cut along the edges, and you unfold it. So this is going to fling up like this. Everybody see it? And if you flatten it out, hey, how about that? That's pretty cool, right? That was unintended, right? But so you get this fruity snacks, right? And you get, fruity snacks are good, right? You get all of your sides. So when I say unfold to make the net, what I'm talking about is visualize you need to visualize pulling it apart, okay? So go from your rectangle and then just think of expanding it. What I will tell you everybody forgets about, they forget about this piece. They always forget about the skinny ones, right? Because what happens is they'll draw a picture and they'll forget that there's this little chunk in between, okay? So, everybody see that? We cool with that? So, if you need to draw that, go ahead. If you don't need to draw it, you can skip it. Okay? Yep.
Wait, are you going to add an answer?
We're going to, yeah, in a second. Yep.
No.
Yep. The next step we need to do is to find the area of each piece. Find the area of each piece. That's not quite right. I think so. To do these, guys, please notice that you can use shortcuts when possible. Notice here that the front of it, the box, is going to be exactly equal to the back of the box. Do we agree with that? So let's say that this is the front and the back. We'll do that in blue or black. Notice that the sides are exactly the same. Two sides are going to be the same. So this is left and right. And also notice that the top and the bottom, top and bottom, are all going to be equal. Does that make sense? So don't do more work than you have to. Instead of finding 6 here, you only have to find 3, right? Okay. Danny?
I was going to say, instead of like finding the area of the small rectangle, can you find the big rectangle? I mean, big square? The green and the red?
The green and the red.
Or, 5.
Oh, so you want to combine black and red?
Oh, back.
You could. I think that would make it trickier, and you might make more mistakes. So, good. Carlos?
It would be much easier if you look at the 3 shapes, find the area of the top, rectangle on the side, multiply the sides by 4, and the top by 2.
But not all the sides are going to be necessarily equal. See the sides here, the red and the black? Those are not. Those are all sides, but they're not equal. Okay? So be careful with that. We're doing exactly what you said, but you said find the side multiplied by 4. Well, here's the 4 sides, but those are not all equal. Okay? So, dimensions of the front and the back. The front is 5. It's 5 centimeters by, what's the other distance? 6. 5 by 6 centimeters. Notice that the 6 here is going to be here and here. So notice that the black is 5 by 6. What is the dimensions for my red? What are the dimensions for the red? 2 by 6. 2 centimeters by 6 centimeters. And what are the dimensions for the top and the bottom? 2 by 5. So 2 centimeters by 5 centimeters. And then the last thing we need to do is write the area. Well, they're all rectangles, so it's length times width. 5 times 6, this is going to be 30 centimeters squared. The left and the right side are both going to be equal. They're going to be what times what? 2 times 6, so 12 centimeters squared. And the last one, the top and the bottom, is 2 times 5, so it's going to be 10. Oops. Oops. 10 centimeters squared. And then perfect. Your next step, step 3, is to add them all up. Now, 1 second. Remember, add the areas of all the faces. I told you to look for shortcuts. This is one of your shortcuts. Don't find all 6 of them, because you know they're going to be equal, right? The front is going to be the same as the back. So your last step is, just as Arden said, to multiply all of them by 2, because there's 2 front. There's the front and the back, right? Plus 2 times, let's see what else we got, 12 for the left and the right, and then plus 2 times the bottom, top and the bottom, okay? So we get 60 plus 24 plus 20. This becomes 44 plus 60. So we get 104 centimeters squared, okay? Basically, this boils down into a huge area problem, right? You know how to find the area of a rectangle. Now you're just going to have to do it for a bunch of different sides and add them all together. Asia?
So you add, you multiply from
By 2, you mean? Yes, because the order of operations multiply comes before division. Carlos? Is that right? Sarah?
So didn't we just do 2 times times the height times 2 times the length times 2 times the
No.
You have all the...
Because 2 times the length would be 2 times, you would have 2 times like 6, plus 2 times 5, plus 2 times 2. You need to do 2 times the area, not just the length and the width. Okay. Arden?
I think you could say that, like, add the person to top of the
Correct. But the way I've written it, you have to do the multiplication first. You could combine your terms into a parenthesis. You could do that. All right. Carlos?
You have to do the math in 5 minutes to get that.
You can do it however you want. You get it right, that's fine. Just get it right. This is the easy one. I wanted to show you the method to do it because they're not going to be as easy, okay? We're going to skip this one. You guys seem to be okay with this one, okay? Is that all right? All right, the next thing we need to do is cylinders. The same process for cylinders. Think of a soup can when you think of cylinders. The only difference between a cylinder and a prism, the top and the bottom now are what? Circles, okay? And we call the other piece the height. Cylinder here. So here's a cylinder, all right? Notice the top and the bottom are circles. These are a little bit harder to visualize, forming a net. You have to think about exploding the top and the bottom off like this. So you get this piece, and then you will get the bottom circle. All right, it'll be the same size, but I don't have another one. And then the hardest part is you have to picture unrolling that middle piece. Okay? You need to picture unrolling that middle piece. Because if you have a piece of paper like this around it, you're going to explode the top part off of it, right? And then the paper is going to unroll. Does everybody see how that forms? So if you wrap it around, it's going to make the whole shape. Well, close. My paper isn't quite long enough. And when you explode it, it becomes, what is that piece of paper now? Rectangle. That's the hardest thing for people to see. It's a rectangle, it's just wrapped around, okay? Yep.
Here's a rectangle, then why do you find the area by the r squared?
We don't find areas in 2 pi r. This is
2 pi r 8.
okay. So let me show you why this shows up. Is everybody okay with the explosion, the net? Is everyone okay with the area of the 2 circles?
Yeah.
Pi r squared. The problem then is, well, how do I get this area right here? 2 pi r h. H is the height. So I have my rectangle. H is my height. Everybody's okay with that? The hard part comes, I need to do h times whatever the other side is. Now, you see this light green line? Sorry, that was supposed to be green. See this green line right here?
No.
It says that that is 2 pi r. What does 2 pi r stand for? Do you see that this green line is repeated right here? Because when we unravel, you see the circle? You see how this is the circumference of the circle? So when we unravel this, it's going to be exactly the same length. Does that make sense? That's the hardest thing to see. All right? Correct. So this is still length times width. You have h right here, and you plug in 2 pi r right there, so you get 2 pi r h as your final. One more time just to show you. Here's your cylinder. Notice that the top is a circle. The distance around a circle is the circumference, right? As I break this open, notice the green piece will be on top. As I break it open, it's still on the top over here now, but that's exactly the same as what it was in the circle, right? I didn't make it longer or shorter. So therefore, this distance has to be the distance of the circumference, which is 2 pi r. Is that clear? That's the hardest part. So find the surface area of a cylinder with a height of 18 centimeters and a radius of 10 centimeters. Height of 18, radius of 10. Draw a picture. The easiest way to draw a picture of a cylinder, two circles right above each other, connect them on the side. So they're going to be they're not going to be straight circles. They're going to be ovalish. So really it's going to be two ovals. Okay, it's kind of a flattened circle. Alright, and then you probably have to fix it because you messed up. Alright, that's perfectly fine with me. It does not have to be perfect, okay? Carlos?
For the, if you go back, for that one, find the area of the whole cylinder, you have to multiply pi r squared times lateral area.
Not to find the area of the hole,
I mean the
surface area, you need to do the base times 2, because there's 2 of them, pi r squared times 2, plus the lateral area, which is 2 pi r h. Okay?
Wait. 1, 2,
The radius is what here? 10. The height is 18. Alright, whatever, I'll just pick them up later. We have 2 circles, remember? Okay? And then when we unfold, we have the wrap around the cylinder. The area of my 2 circles is what? How do I find the area of a circle? Pi r squared. So we get pi times, what's my radius? 10 squared. So we get 100 pi. Is everybody okay with that part? Okay. Now, to find the other parts, what's the height of this piece of paper going to be? The height this way is still 18. Alright, sorry, it's not quite to scale. But the height of that paper is still 18. This distance is the same as the circumference of the circle, so it's what? 2 pi r. Well, 2 pi r is 2 pi times what? 10. So 2 times 10 is? So this is 20 pi. Are we okay with that? So the area of this is the length times the width. So it's area is equal to 18 times 20 pi. No, you should simplify that out. So that's going to be, the area of this is going to be 360 pi. Okay, and you just have a calculator if it's really hard numbers. The last thing, put it all together. So how many circles do I have? So it's going to be 2 times the circles, so 2 times 100 pi, plus what? 360 pi. So you get 200 pi plus 360 pi gives me 560 pi. What are my units? Remember, it's an area. Centimeters squared, because it's a surface area. Right? How do we feel about that one? Yes, ma'am. You can leave it in pi as with the last chapter. If you leave it in pi, that's fine with me. If you want to write it as decimal, that's fine too. Okay? Yes, ma'am?
For the 20 pi, I understand the radius is 10.
Mm-hmm.
So would that part count as like when you open it?
What do you mean count as?
Well, would it be the same, like you said, when you open it, it will be like the same, like 2 pi r?
Correct, because this matches up. See how this blue is stolen from right here? Because it wraps around that? So when you unravel it, this blue line is going to be the same as that, right? Because it wraps all the way around and it seals it. And so this is a circumference, so it's going to be 2 pi r of whatever that is. Always, okay? Always. As long as it's a cylinder. Yes, ma'am?
Even though it doesn't have size and multiply, right?
Where?
18 and 20.
Yes, you can multiply them, you can't add them. So you could multiply 18 and 20, you couldn't add them. Abinant? So the lateral area would be just the sides. So your lateral area here would just be 360 pi. But I wanted the surface area. So surface area is everything. Okay. Carlos?
It comes under the lateral area of this area, 1/8, right?
Correct. Very rarely would you be asked to just find the lateral area of the cylinder. Last problem we're going to do today. Find the height of the cylinder shown if the surface area is 157. So notice that they've given you the surface area this time, and they ask you to find the height. So it's a little bit more difficult, Danny.
So if they say the area is 157.08, do we have to use 157.08?
Yes. You shouldn't until the very end. Okay. So what we need to do here, draw a little sketch if it helps. Circle, circle. What is this distance right here going to be? H. What is this distance here going to be? 2 pi r. What is pi? Or what is r, sorry? So it's going to be 2 pi 2.5. Does that make sense to everybody? So my area then is the area of the circle. I have 2 of them, right? So it's going to be 2 times, what's the area of a circle? Pi. So it's going to be pi 2.5 squared for pi r squared. Does that make sense? Does that make sense, people? All right. And the area of the rectangle, which is going to be what? H times what? 2 pi times 2.5. What is 2 times 2.5? 5. So it's going to be 5 pi h. All right? Having it? 2.5 is the radius. Tells us right there on the bottom right. So wherever you see 2.5, I'm plugging in the radius. All right, guys, the last step. We need to add both of these together because they gave us the surface area. Does that make sense? So we get 157.08 equals 5 pi h plus, this is going to be 2 times pi times 2.5 squared is 6.25. All right, and I'll give you a calculator if you need it. And then we just have to clean it up. How many variables are there? What are they? Is pi a variable? Pi is a constant. Even though it's... Guys, pay attention, please. This is a huge mistake. Even though pi never ends, it is always a constant. Because pi is never 4. Pi is never 6, right? Pi is always 3.14156, whatever, 15, whatever it is, right? Did you hear that? So it goes on forever, right? But it never changes its value. That's why it's called a constant, right? So how many variables do I have? 1. Can I solve an equation where there's only 1 variable? Yeah. So clean this up a little bit more. 157.08 equals 5 pi h plus this is going to be 12.5 pi. You can solve that, right? I don't have a calculator, but you can solve that. This would become some decimal. Subtract it from both sides. All right? I don't want to do it, okay? Well, I don't want to do it without a calculator. I could, it's just waste time. All right, any questions on how we set this one up? Having it. Guys, listen up, please. I can't hear Abinette. Where did I get the 5 pi? Because the area of the rectangle is this times this. Do you agree with that? 2 times 2.5 is 5. So I get 5 pi from up here times the h, so I get 5 pi h. Okay. Something to think about. Just think about that one. It might be a good thing to chew on later today. We didn't get to it. Which cylinder would have more surface area? Cylinder A has twice the height as cylinder B, but cylinder A has half the radius. Think about that. If you got an answer, come talk to me, okay? So cylinder A is twice as tall, twice the height, but the radius is half as much. Which one has more surface area? Okay? You need to come up with an answer and a reason, all right? Yes, ma'am? Yes. Your homework for tonight is right here. There is nothing from the first section, just the second section. The one thing I also wanted to mention, cylinders are used a lot in real life. Obviously with like juices and, you know, like a 20 liter is like a cylinder, kind of. Okay? Because it has the weird ends. But cylinders are used all the time for gases. If you ever see on the highway like the truck with the oxygen tanks in the back, it's always in a cylinder. Cylinders are good for gases because they have no weak spots. Gases always expand into whatever shape they can occupy, right? And so for containing gases, it's only as good as the weakest point, because otherwise it will break. Cylinders are great because they don't have very many weak points, right? This is the pipe organ in the bottom of the crypt church in the basilica. There's beautiful 4 p.m. Mass. And the length of your pipes, the length of those cylinders, determines what type of note you have. The longer the pipe, the lower the note. Okay? So if you have those little tiny pipes, they make the really high notes. Everybody got it? Yes, ma'am. Test grade? Yes.
Do you have the test?